All right, so for example 1, it says in 2000, the population of Africa was 807 million, and by 2011, it had grown to 1,052 million. Use the exponential growth model, A equals A sub 0 e to the kt, in which t is the number of years after 2000, to find the exponential growth function that models the data. All right, so they told us we're going to use our growth or decay function. So let's go through our variables. We're going to find A sub 0, K, and T, correct? So it says, in 2000, the population of Africa was 807 million. What is that 807? That's our starting amount, so that's our A sub 0. And by 2011, it had grown to 1,052 million. So what's that 1,052? That's my ending amount. All right, and it says T is the number of years after 2000. So do we know how many years it was after 2000? 11, because my ending amount was in 2011, right? So what is the one variable I don't know? I don't know K. So we're going to have to go find K. But is that really what we're after? It says to find the exponential growth function. So we're going to find K and then plug that in and write a function out of it, okay? So we're using this equation. Let's plug in what we know. Oops, wrong number. All right, so where's my variable? Yeah, it's in the exponent, right? So I need to get this part by itself. So what do I need to get rid of? How do I get rid of the 807? Divide it, because it's being multiplied times the part I just circled. So we're going to divide by 807. So when we do that, we can just leave it as 1052 over 807, okay? You don't have to put in the calculator yet. Equals e to the k times 11. I'm just going to write it as 11k. We're okay with that? Yeah. Now that I've got the exponential part by itself, how am I going to get that k out of the exponent?
Move it to the front.
Move it to the front. In order to move it to the front, what do I have to have? A log. So we're going to log both sides, because what we do to one side, we do to the other. So log both sides, and now I am going to move this to become the coefficient, because it was the exponent. Now,
why is log at the end? Oh, you moved both of them.
Why? What did I do that I probably should change? No. We want the 11 to come on over too. The log. What did I do wrong with my log? Yeah, I mean, it's not wrong what I did, but it's easier if we do natural log because we have that E, okay? So let's change where we said log. Let's put natural log. Sorry about that.
Would you erase it or fix it?
I'm going to erase mine. Just the log.
Why?
Because we had an E in the problem, and so we should go ahead and use the other. It won't matter in the end, but I'm about to show you something that's going to make this easier, and it only works if I have natural log of E.
So we'd have to use the log.
We're logging both sides. We're just going to use the natural log instead of the common log.
Yeah.
All right, so make sure we fix that. Sorry about that. All right, just for grins and giggles, let's go to our calculator and let's type in the natural log of e. Now, when you type in e, it's going to ask for an exponent, so put a 1, because that's what its exponent is right there. So try that and let's see what we get. All right, so when you worked out your natural log of e, you said it gave you 1, right? So what is 11k times 1? So as long as it's being multiplied, guys, the natural log of e just automatically cancels. Okay? Because it's 1, and 1 times anything is anything. So I want to solve for k. What am I going to do with that 11? Divide. So let's divide both sides by 11. So we got k is equal to the natural log of 1052 over 807 over 11. And now that we're at the end here, let's just go ahead and type that in our calculator. Just make sure you type it like it's written. Close the parenthesis after your 807, and then put your divided by 11. All right, so you got k was 0.0 what? So 0.024. That's what you got? Good. All right, so, but now remember it told us to find the exponential growth function. So to do that, we're going to replace every variable except, we're going to leave the letter a in it because we want to be able to find an ending amount given a certain amount of time. So a and t are going to stay a and t. We're just going to change the rest of it. So we're going to have a equals, what was my beginning amount there? What was my original amount? 807. E, and we know k, what is k? 0.024, and then we're just going to put the variable t. And that is our function. So based on this now, I can ask you, using their data, what they were going to predict the population in Africa to be in 2019. You could plug in t is 19, and we'll get a number telling us our predicted population, right? Or if I give you the population, we can find what year it occurred. So there's our function, our model. All right, so then it asks, by which year will Africa's population reach 2,000 million? Which is the same as saying 2 billion, but remember our numbers before, our beginning amount, our ending amount were in millions, okay? So that's why it says 2,000 million. All right, well, we have an equation, don't we? We just found it. Remember, the a equals 807 e to the 0.024t. And we want to know when it's going to reach 2,000 million. So is that going to be an ending amount, or is that my time? Yeah, that's my ending amount. So let's plug in 2,000 for a. And we want to know by which year, so we need t, don't we? So how are we going to solve this? Where is t at? In the exponent. So we got to get that exponential part by itself. How? Divide by the 807. And so I don't know what that is, so it's just going to leave us 2,000 over 807. This way we're not making a rounding error in the middle of our problem, okay? It's going to be exact until the end. And that's equal to the e times 0.024t. Now I've got the exponential part by itself. How can I get that t out of the exponent? What's that? Log it, because we have an e in it. Which log are we going to use? Good. So use your natural log. So natural log both sides. Then what can we do with that exponent? Move it to the front of its log. Is that a natural log of E? What is the natural log of E? 1, so we don't have to put it. So how am I going to solve for t? Divide by the 0.024. And so we have t is equal to the natural log of 2,000 over 807 divided by 0.024. And so we're going to find t, which is equal to, so t is approximately what number? 37.8. Well, I guess that would be exact, huh? No, it kept going. Okay. So which is approximately what is a whole number? 38. So in 38 years. But it said by which year? So what year is that going to be if t is 38? Remember, t was the number of years after 2000, right? So what year is it going to be when it reaches this? 2038. So because it's a word problem, we're going to answer with a complete sentence. So by 2038, Africa's population will reach, and you could either write 2,000 million or we go ahead and put 2 billion. And there's our solution.